Okay, well, this is going to be one of the harder lessons that I put onto video. And in fact, I may spend some time on Wednesday with you guys when we have class hours showing you some more of this. But what I wanted to do was to give you some applications for electromagnetism. And perhaps the most, I gave you one, the telegraph, but we don't really use the telegraph anymore. But what we do use is an electric motor. And we also use things like loudspeakers. Your earphones work off of electromagnetic principles. So what I'm going to try and do, and I'm just going to do the best I can, and then like I said, I'm going to have to show you some more of this. I'm going to explain the basic principle of an electric motor. And let me start with this. If I have a wire that is in a magnetic field, so we have north-south. If I have a wire right here, we learned last time that wire is coming out of the board. And because of that, it has a magnetic field that goes around this way. And as a result, that wire is going to get pushed up out of that magnetic field. Now, imagine that I had two wires, one that was coming out and one that was going in. Oh, the one that's coming out is going to get pushed up, and the one that's going in is going to get pushed down. If I was to take those two wires, and I was actually to make a wire like this, and if you can imagine, and I'll show you this hopefully a little bit better here in a second, these two wires going into the board. Now what you essentially have is a loop of wire. It's kind of hard to draw this, but it would be something like this coming out of the board. And what's going to happen is one side of this will be pulled up and the other side will be pulled down. Let me try and demonstrate this for you. And I'm going to have to use, this is really hard to do, but I'm going to do the best I can here. Let me move this off of here. Let me pull it back this way. Pretend that this is my north and my south, and here is my wire. Okay, by simply putting that coil of wire in there, if I run a current through here, by the way, north to south, let me turn it this way, it'll just be easier for me. No, it was better the way it was north and south. Be like this. If the current is going in this way, this wire, the current is flowing this direction, it's going to be pulled up. This wire, the current will be coming the opposite direction, and it'll be pushed down. And as a result, we're going to get what's called a torque. It's going to twist. But as soon as it gets to there, it's going to stop. Let me turn it slightly to the side. That's because the top is being pulled up by the same amount of force as the bottom. So what we've just constructed is the ability to get this to turn a half a turn. That's not very exciting. But what if we could keep it turning? Well, one way to do that would be to somehow switch the direction of current so that once it got up to here, I switched the direction of current. So the current was going this way. Now let's say it's going the opposite direction. Especially if we changed the current right after it got to the top, then it would spin one more time. And if we could do that every time we got to that top position, spin it over, we could make the motor keep working. Unfortunately, if I did do something like that, let's say somehow magically I could change that, every time I did this, my wire would tangle up. And before long, it would be all tangled. So the question is, what do you do about that? And the answer is, you can take this wire and you can connect it to something that can slide across something else. And with a electric motor, I'll come back to that in a minute, what we do is that we will have our wire, usually think of it like that, And this comes up, and we put on here something called a brush. And then we put around it something that the brush rubs against. And this is electrified. So it's hard to see this. My drawing's not real good. But as this twists, this will rotate. And although the current, we've got positive and negative, as it turns, it switches. But because this is free to slide over the brushes, this is called the stator and the brushes. The brushes are free to slide. They don't get tangled up. So let me show you an electric motor. This is an electric motor that a student built many years ago. Let me pull that back a little bit. And I will show you another one that's like this. Now, this is called a DC motor. Let me turn it this way. I'm going to put electricity in here and here. That electricity is going to do two things. First of all, there are wires that are running. It's hard to see them, but they run to this, and they make this into an electric motor. If you think about it, if the electricity is going this way through here, this would be the north and this would be the south end. And then, by the way, this is a motor with two coils. Each one of these coils inside of here becomes its own electromagnet. So let's take this side. If I was to grab that, this is the north end. And by the way, this side over here would be the south end. These two are connected together. If I turn this and do the same thing, if the electricity is flowing through this direction, this is the north end and the south end. I wish we could see that a little bit better. Maybe I can do it a little bit better with this one right here. This is the same idea. So what I've got is, this is my electromagnets on this one. The electricity comes in. You can barely see it. There are green wires. Let's see if I can turn that so you can see it. There are green wires here, and they go around. So this becomes an electromagnet. This and the one on the bottom are connected together. So I've got a north and a south pole. There's a reason for 4 of them. There's a little video I'm going to have you watch, and it'll help to explain that. Now, I'm going to use that one here in a minute, but if I take this one, this down here is where we're doing our connections. I don't know if you can see it, but right in the center there's kind of a black line. That is an insulator. This copper is a conductor. And so as this, and these are the brushes right here. This little thing right there is a brush, and there's one on the other side. So what happens is I have, let's say, positive here and negative here. Right now, the electricity is going into that stator and this one on the other side. And that's sending electricity through to, boy, this is so hard to do, to this one right here. And because of that, it gets pulled up toward the top. So that's a better way to look at it. It gets pulled up toward the top. Right when it gets to there, if you look at what happens, it has just passed that spot where it was an insulator. And you have now switched the direction of current, because now we're going to, and sending the electricity through this one. So what happens is every time this makes a quarter turn to right there, they're going to switch the electricity, turn it off on this one and turn it on this one. And it keeps on going, and it just keeps moving around. This one right here is the best electric motor that I've ever had built. And I want to show that one to you because it's kind of interesting to see it work. This is nothing more than just a DC power supply. DC means that it's sending voltage in one direction only. And if I put this on and turn this on, that motor will start to turn. and I can slow it down a little bit or I can speed it up. This motor, I wish I could show you this in class. This is, like I said, this is the best electric motor I've ever had built for me. I usually do this as an extra credit project. This up here is where the brushes are. And it's interesting, he actually made the brushes out of little pieces of aluminum can. So he's got the same thing. Right here is that metal that you can see, but he has a brush, which is just a little piece of an aluminum can that touches. And say right here, now this one is being pulled up, this one's being pushed down. When we get to right here, we switch the direction. Now the next one is being pulled up. And every time I get to right about there, or right about there, we turn off the electricity and switch it. And it makes a quarter of a turn each time. So that is one application. Here's another interesting application. Just a second. And that is a loudspeaker. See if I can turn this on. I have, on this computer, I have hooked in this little coil of wire. Right here, this little coil of wire. That coil of wire, move that over so you can see it. That coil of wire, when I turn on, and I have the Hallelujah chorus playing here, and it's playing at full volume. When I have that, this is sending signals from my computer, and if, as you know, it's making that into a magnet, right? Because you're sending current, but we're switching the direction of the magnetic field. I have a cup, and if I bring this cup to this, pull that away, pull it away, and that is all there is to a loudspeaker. Now you say, well, what magic is causing this? It's actually fairly simple. Inside of this, there is a magnet. By the way, it works a lot better if I hold it down here. There's a magnet inside of here. Well, what's happening is this is becoming a magnetic field. And this is vibrating back and forth, just like our voice box does. So as soon as I bring that close, this is vibrating because the signals coming from my computer are mimicking the signals that would be producing the sound in my computer. And now, when I put it against the magnet, this magnet is being pulled back and forth, and it's vibrating the cup, and it's actually making that sound. You can make a loudspeaker at home. And great song to sing right here as we come up to Easter, the Hallelujah chorus. But I can set that on there, and it'll keep on playing. There are other applications of electricity and magnetism. By the way, the first person to ever make an electric motor was Michael Faraday. And he actually made it by taking mercury, putting it in a bowl, putting a magnet in the center, and then running an electrical current between the magnet and the wire. And it created a circular magnetic field. And he was able to get a wire to move in a circle. So this is an interesting section because there's not really a homework assignment that goes to it. But I do have a homework assignment. I would like you to build me an electric motor. You're going to need to build one and then film it for me. Now, that may be challenging. You need a fairly strong magnet. You can order those online, but I know things aren't coming quite as quickly as they used to. You used to be able to get things in one day. If you have a hardware store that you can go to, if your family goes out, you can get fairly strong magnets at a hardware store. You might find magnets laying around somewhere. But what you need is a magnet and basically some wire and a battery, and you could build a motor. So the assignment is to build me an electric motor. I'm not going to put any other conditions on that. If you look online, you will find plans for electric motors, some of which are very, very simple. And the goal is to get it to spin. And that's all I care about. So that is the assignment for this. And we'll talk about that more. I'll show you on Wednesday some other motors. I don't have them here. I have them at school. So that finishes chapter 24. Now chapter 25 we'll go into, and then we'll do a test off of kind of a mini exam off of electricity and magnetism. Chapter 24 and 25, and we'll talk about the other stuff next week when we meet. All right, that's the end of chapter 24. That was lesson 4. And there is a video I want you to watch on electric motors as well as this video, but that'll be in the lesson assignment.